Section 2.7, Linear Inequalities. A linear inequality resembles a linear equation, but with an inequality symbol instead of an equal symbol. For example, y is less than or equal to 2x plus 1 is an inequality, and y equals 2x plus 1 is a related linear equation. So remember, inequality symbols are things such as greater than, less than, greater than or equal to, or less than or equal to. The graph of y equals 2x plus 1 separates the coordinate graph into two regions. The line is the boundary of each region. So notice that right here, this separates, this line that we have here separates, and this is what we call our boundary line, and separates our graph into two different regions. The graph of y is less than or equal to 2x plus 1 is the shaded region. So every point in the shaded region satisfies the inequality. So when it says satisfies the inequality, it means it makes a true statement. So for example, if I were to pick a point in my shaded region, such as the point 1, 0, oops, and plug it into my inequality equation, so y is less than or equal to 2x plus 1, it should make a true statement. So 0 is my y-coordinate, is less than or equal to 2 times 1 plus 1. So 0 is less than or equal to 2 times 1 is 2 plus 1 gives me 3. Does this make a true statement? Is 0 less than or equal to 3? Yes, so this is true, and that's why it is included in my shaded region. So that means any point that I pick in this shaded region will always satisfy the inequality and make a true statement. Whereas if I were to pick a point on the other side, such as negative 2, 0, and plug it into my inequality equation. So 0 is less than or equal to 2 times negative 2 plus 1. 0 is less than or equal to negative 2 times times positive 2 gives me negative 4, plus 1 is negative 3. And notice that this is not true, which means it's false. So therefore, that's why it was not part of our solution set. So that's the difference between what we're going to do when we're graphing inequality equations, is that we don't just have the line as our answer, we have also a shaded region that we need to include. If the inequality symbol is less than or greater than, we're going to use a dotted line to draw the boundary. If the inequality symbol is less than or equal to or greater than or equal to, we're going to use a solid line to draw the boundary, because when it's equals to, that means that points on my line, so any point, since this was equals to on this line, if I were to plug it into my inequality equation, it should make a true statement. Whereas if it was dotted, then instead, if this equation that we have right here was y is less than 2x plus 1, I would have had to make my boundary a dotted line, and then those points on my boundary line would make my inequality statement a statement that was not true. So let's go ahead and practice graphing these. So given 2x plus 3y is greater than 6, the first thing that we want to do is write our inequality in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. So the only difference is that we're not working with equals, we're working with inequality symbols now. So I'm going to rewrite my equation over here. 2x plus 3y is greater than 6. With this equation, I want to solve for y. So the first thing I want to do is get rid of anything that does not have a y attached to it. So I'm going to take that 2x and try to get it to the other side. And to do that, I'm going to have to subtract it. So then negative 2x and 2x cancel out. This leaves me with 3y is greater than negative 2x plus 6. And then I'm going to have to divide everything by 3 to get y by itself. And now my equation is going to end up being y is greater than negative 2/3 x plus 2. And had I right here been dividing both sides of my inequality equation by negative, I would have flipped my inequality sign, but we did not do that here, so I don't have to worry about that. So remember, how do you graph a line? Well, we have to determine what our slope is, in this case negative 2/3, and our y-intercept is 2. So on my graph, I'm going to start with my y-intercept, which is 2, and my slope is negative 2/3, so I'm going to go down to right 3, down to right 3. And then it says determine whether the boundary line should be solid or dotted, and then graph the boundary line. So if we look at our equation, notice it's not equals to, so we know that it is going to be dotted. And so I'm going to take my ruler and I can make my line dotted, or you can draw your line and then erase the part so that it becomes dotted. So now that I have my boundary line, which is again a dotted line because we're not equal to, I have to figure out which region I'm going to shade. So choose a point that's not on the boundary. Usually 0, 0 is a good choice if it's not on your boundary line. Because it's easiest to plug into your equation. So I always like to write down the point that I'm going to pick to test. So I'm going to test the point 0, 0. And I usually like to test it in the original equation before I changed it for y to solve for y, because this way if I made any mistakes, at least I can shade the correct region. So plugging 0 in for x and 0 in for y. So when I do that, 2 times 0 is 0, and 3 times 0 gives me 0. So is 0 greater than 6? No, this is false. Since this is false, it says for number 4, if a true inequality results, we're going to shade the region containing your test point. And if a false inequality results, we're going to shade the other region. So in this case, we got false. So where is 0, 0 on my graph? Remember, 0, 0 is right there. So this is not included in my solution set. So that means I want to shade the other side of my boundary line. So I'm going to get my highlighter, is what I usually recommend to help you shade your region, because that way if you make a mistake, you can go over it with a pencil and shade a different region if you need to. So everything on this side of my boundary line is going to be a solution to my equation. Things on my boundary line are not going to be solutions, because if I were to plug them in, they would not work since it's not equals to for my equation. So then that is my graph and what it should look like. So another way we can tell where we're going to shade is just by looking at the inequality. So I'm going to erase this right here so I can write down some stuff. So if I have a line, or if my inequality is y is greater than, or y is greater than or equal to, notice y is greater than, so that means you're going to shade above your boundary line. So straight above your boundary line. And if y is less than, or y is less than or equal to, when you solve for y, you're going to shade, so this would be shade below your boundary line. And again, if you get stuck, then you can pick your test point and just to double check to make sure where it is you're shading. And again, just remember that the test point you pick cannot be a point from your boundary line. So let's go ahead and practice coming up with the equation given a graph. So looking at this graph, if I want to come up with the equation for this, for number 1 it says choose 2 points on the boundary line and determine the equation of the boundary line using, and of course if we're choosing 2 points we're going to use, if you look here, point slope form. And so that's one way we can do this. So if I picked a point here and pick another point on a grid mark right here, I could then from there find the slope by doing my slope formula, and then I could plug into point slope form and then solve for y. Another easier way to do this is, remember, if we know that we can find our slope, which is rise over run, and we can look at the graph to find our y-intercept, that's going to make this equation a lot easier to graph or figure out the equation for. So what I'm going to do is I'm going to find my y-intercept, which is right here. So 1, 2, 3, 4, and it's positive. Now I'm going to do find my slope. So in order, if I go from left to right in my graph to get to the next grid point, which is right here, I have to go down 1, 2, 3, and right 1. So this is down 3, right 1. So -3 over 1, and I don't need to write over 1. I can just write -3. So the equation for this then would be y is equal to -3x plus 4. But remember, we're not done because we have a shaded region to my graph. And since we have a shaded region, that means that we need to figure out which way my inequality is going to go, and if it's greater than or equal to, less than or equal to, or if it's greater than or less than. So change the symbol of your inequality to one of the greater, less than or equal to, or greater than or equal to if your boundary line is solid, or change it to a dotted line if it's less than or greater than. And you can also do what we did before, choose your symbol also on the which side you think is shaded, and then write the inequality. So if I look here, it looks like my shading is below my line, and since I think it's below my line, and also notice that the line is solid, so I know I'm going to be equals to. So because of this, I'm going to test the line equation y is less than -3x plus 4. So in order to double check my equation to make sure that I pick the right one, I'm going to choose a test point from the shaded region and substitute it in for x and y into my inequality equation. And if the test point makes a true statement, then the inequality symbol you have chosen is correct. So let's pick a test point. So notice that 0, 0 is right here in my graph. It's not on my boundary line, so that's what I'm going to pick to test. So I'm going to test, I'm going to write down here, the point 0, 0, and plug it into my equation. So I have 0 is less than -3 times 0 plus 4. So 0 is less than -3 times 0 is 0, and then plus 4. So does this make a true statement? Is 0 less than 4? Yes, this is true, which means that my inequality equation was correct, and this is going to be my solution. And notice one thing that I did forget to put on my equation is that because it is a solid line, it should be less than or equal to. So make sure that you change that to less than or equal to on your equation. So note, if you pick a test point in the non-shaded region, substitute in for x and y, and it makes a false statement, then you have chosen correctly. So the vice versa, if that's also true, but I find it a lot easier just to always pick a point in your shaded region. If it makes a true statement, then you did a good job. If it doesn't make a true statement, then you would have to flip your inequality so that it would go the opposite way. So as I said before, generally if your shaded region is above the boundary line, you're going to use greater than or equal to. If it's below the boundary line, you're going to use less than or equal to. And if you're ever unsure, just always pick a test point and check. So absolute value inequalities are solved in a similar manner. So we're going to graph y is less than the absolute value of x plus 1. Since the inequality symbol is less than, the graph of the related equation y equals absolute value of x plus 1 is dashed. So the first thing we want to do is graph our equation. And if you remember from the last section, we learned how to do this. The first thing I want to do, since it's an absolute value equation, I want to figure out what the vertex is. Oops. And the vertex for this equation is going to be 0, 1. So I'm going to put that in my graph first, which is right here. And then I could make a table or look at my calculator to help me graph the rest. I know that the rest of my graph is just going to be a dotted line going like this. And remember, it's dotted because we are not equals to. So now I have my absolute value on my graph. And now I need to figure out which way I am shading. So notice that our symbol is y is less than. So this tells me that I'm probably going to be shading below the absolute value boundary line that I made. But if I'm unsure, I can pick a test point and notice that 0, 0 is not on my boundary line. So I'm going to plug that into the original inequality. And when I do that right here, I get a true statement, which means I am shading below my inequality. So I would have been correct in doing so. So let's get my highlighter because it's always easier to use a highlighter when you're doing your shaded region. So with my highlighter, I would shade everything that is below my boundary line. So that means that anything in this region, if I were to plug it into that inequality equation, it would make a true statement. And that's our graph. And so again, the key to remember is that you want to first graph your line or equation, and then is it a solid line or is it a dotted line, depending on if it's an inequality that's greater than or less than or greater than or equal to or less than or equal to. And then you have to, after you do that, figure out where do you shade your region, because since it's an inequality, we have multiple answers that could possibly make our inequality statement true. So we will in class then on Monday go ahead and figure out how to do some more of this graphing. So make sure that you have your notes with you, and you can always go back and watch the video again if you need to.